Yeah, I mentioned many times this class is not purely R class. It's based on statistics and using R. The lecture based on statistics. So today we will cover correlation analysis. The next week we will cover regression analysis. And then following maybe hypothesis test and so on. So correlation analysis, you know, some of you take my research methodology class. I covered correlation analysis in the class. Anyway, correlation analysis is one of the important part in statistics, because in many cases we use this correlation analysis in research. So we can use Excel. We can use other program, but this class is using R. So today, correlation analysis, I think you know already about this. Okay, so kind of repeat correlation analysis using variables, X variable, Y variable, and so on, then find the relationship between two or three or more variables. So the study of the relationship between variables, X variable and Y variable. This is also defined as a group of techniques to measure the association between two variables. I checked earlier that for next semester my classes, one of them is data mining. Ellie, you are going to take data mining, right?
Yeah, I have registered for data mining and policy formulation, both under you.
Yeah. Kenny, you took, right? Earlier.
I took that class earlier, yes.
Yeah. At the time, you know, we used analytic solver.
Yes.
But the problem was the license. So at the time, I changed it to use Excel for the data mining. But the next semester, I'm going to use this R.
Data solver. I cannot do it again.
Yeah. So Elia, I think this is this class have it's like prepare for next semester.
Yeah.
Because I'm going to use R for the data mining.
Okay, that's great.
Okay.
She'll know everything ahead of class.
I'm excited.
Okay. So anyway, using R correlation analysis today. So as you know, correlation analysis find the relationship using this R, correlation coefficients. So R, if we use formula, then using this formula, find the relationship. And then this R, correlation coefficient between -1 and +1. So if relation R score is closer to 1, +1, then direction is like this: positively X increase, then Y increase. And if R is closer to -1, then this direction. X increase, then Y decrease. Then 0.5. Usually, when we determine with this R, if it is it has a relationship or not, then usually kind of the boundary is 0.5. Higher than 0.5 and lower than negative 0.5, then we say there is a relationship between. So about 0.5, positive and negative, weak, but there is no relationship, positive and negative. If it is 0, then there is no relationship. And then also, if it is in a curve linear like this, then also R score is 0, non-linear. Okay, R commander. This one is, R itself is engine. Then we use RStudio, right? So R command is similar to RStudio. This one is a graphical user interface. Looks like this. So using a predetermined menu, then we can do like that, Excel. So we can without type syntax, we can do analysis using this R command. Okay, let's open R and RStudio. This one. Okay. To use R commander, we need a package, install package. So if you're ready, then let me know. Sujar, are you ready?
Yes.
Okay. Last time you have some problem to open RStudio.
Yeah.
Okay, now, by the way, we need the data. The data I sent you a link. So we will use data. Exam anxiety data. Sujal, yeah, you upload the kind of data. Okay, doesn't matter. So we need the exam anxiety CSV data, and then we need the exam anxiety. This one is text data. So we will use those. So first we need make a project. So I already did, but for you. So existing directory. My data is in document chapter 6. So find wherever your data is, and then open. We did many times, so I think you can do it. So on this pane, files, if you can see exam anxiety two data sets, CSV and then DAT data set. So we are ready for data. And then we need an install package. And double quotation, then R RCMDR. This is an R commander, kind of an abbreviation. RCMDR, R commander, then enter. Then this one will install package. If it is done installed, then we need like execute library RCMDR R commander, then enter, execute. If you execute that R commander using a library, then you can see this R commander pane or window. So R commander looks like this. We can make it bigger, like this.
Dr. Kim, I get a dialog box that says,
Will you share your
yeah,
this moment? I will make it available to share. Then I will. Okay, show me.
you see it now?
Yeah, it's coming. Okay, yes.
So the dialog box said that there was some commands that are not loaded. Just let me run it again. No, it doesn't give me the option to run.
Okay. Looks okay, but still executing.
Oh, here it is. It says the following packages used by our commander are missing, and without these packages, some features will not be available. So do you want to install these packages?
Try yes. Okay. Okay.
No, that doesn't want to see it.
Yeah, it's working. Yeah, working.
Is this how it should go?
Okay. It looks like working, but it takes some time. Yes, you got it.
Okay. Thank you.
Mhm.
I'll stop sharing.
Okay. Then using this to use this, this time I will show you. Statistics summary, then it doesn't work because there is no data. So you need import data using to use this R commander. So click data, import data, and so on. So click data, and then import data. And then there are so many menus. First one, text data, import text data. And then if you have whatever SPSS data, Minitab data, or Excel file, whatever, this time we will use this exam anxiety DAT. This one is text data. So we will import this text data. So click import data from text file. Then from a local file, it's in your computer. And this one is based on what method to make a column. But this one is not default, so it doesn't matter. So just click OK. Then wherever your data is, here, exam anxiety D8 data, open. Looks like now we get data. So try this view data set. Then you can see data set like this. So data set looks like this. We import. So this one imported data. So if we want to do correlation analysis, then go statistics, summaries, and then correlation matrix. Click this one. Then this one asks what data, using what data correlation, do correlation analysis. So variable, pick 2 or more. So let's try using anxiety variable. It says pick 2 or more. We will pick 2. Click 1, and then click another. Only 1. What do you think? How can we pick 2? Any idea?
Dr. Kim, you can do shift.
No.
No?
Nice try. Control key. If you use the shift, then like this. But using using control key is one by one. Shift key is all of them. So I will use the anxiety variable and exam variable. So control key and click. And then using Pearson products moment method, then complete observation. We'll take. I will tell about this later. What is complete observation? And then click OK. Nothing in this pane, but look at this here on RStudio. We have the result on RStudio pane. So look at this here, result. So anxiety and exam, our score is negative 0.4409934. So our score is negative 0.44099934. So there is negative correlation between anxiety level and exam score. So that means anxiety level increased and exam score decrease. Anxiety level low and then exam score high. So we can use this R commander do some other statistics. Let's try making a graph. How about dot plot? Not dot plot. How about scatter plot? So using this R commander without type, we can use this R commander. We can draw chart. Scatter plot, X variable, I will use X variable as anxiety level, Y variable, exam score. And just click OK. Create. Scatter plot without type syntax. Using this R commander. So this R commander is kind of a tool to use R easily.
Dr. Kim.
Yes.
Sorry, I did not get this again.
Okay.
I'm going to share my screen again.
Just a moment. Okay. It's okay. No, don't be sorry.
Yeah.
Okay. So there.
Let me close this. So we go to graphs.
Graph. Okay, scatter plot. Click that one. X variable. X variable. Exam. Click exam.
Okay.
It doesn't matter, but the anxiety Y variable, and then click OK.
Okay.
Got it.
I did not click the X and Y variables. Thank you.
We need the X always, specify x and y variable for the same. Excel. We like a scroll down and then specify area.
Yeah.
But this one just click the name of the variable. Okay. Sujar, working okay?
Yeah, that's okay.
Okay. Good. So we can use this R commander. Let's try another one. Maybe we can graph histogram. One of the like a exam score. It's easy and fast. Not very powerful, but we can do it. And you may save this graph somewhere, like using this. So you can make it a PDF or some designate file. It's good. So this one, our commander, I just introduced how can we use our commander, but you may need some like practice based on what kind of data and then what kind of you need. Like here other we can use this one for another test and so on. Okay, that's good. Then clear. Okay, then now go back to R. Using R, we go back to RStudio, and then using this R, how can we do this correlation analysis using R? So we need the data. So as you know, import data, and then I will make a data set name as exam data using this read CSV command, and then we will import this data. Okay, let's import data. So I will make data name exam data. Make and it will be better to okay, if you import the data, then let's draw scatter plot. We did this one last class using ggplot. To use a ggplot, we need a package, install package again. So I will install that ggplot2 package. Install packages ggplot2 library execute ggplot2. So you know this R and RStudio, almost every time we need to install whatever package we need to use ggplot. Install ggplot2 package and then execute using library. And then, you know, let's develop this scatter plot using this ggplot function package. So I will type ggplot using exam data and axis EAS axis x equals anxiety. Yeah, this time use anxiety x variable anxiety. The y variable will be exam score, and then let's using color anxiety. And then we specify like what data we will variable use, and then plus GEOM point scatter plot using point. Why it doesn't work? GEOM, not N. Point. Then plus. You know, just up to that point. Last time we did up to that point. Then plot. Looks like this. At the time, I said, how can we change the color? So I tried to find how can we change color, then include. It's like an adding command about the color change. So using scale color Scale color, where is color? And then gradient. Okay, this one. Scale color gradient. Then if anxiety level is low, then I will use blue color. Then if anxiety level is high, then I will use red. Then color change like this. So anxiety level is low here. Anxiety level is low, then blue. Anxiety level is high, then red. So whatever color you like it from black to white or gray. Let's try in other color like black and gray. Low. Then let's say not gray, white to black. So looks like this. Light to dark. So whatever color you like, you can change. And then I found change this background color. So we will add more command. So add theme, pane. This is actually panel, yeah. Panel, background, and so on. So I will use light green for background. So type, don't need to type or again, copy and paste, and plus theme. And panel, background, elements, and react this one. Then fill, whatever color you like. I will use light, whatever color. Look better. So inside the background, and then I will add this edge color. So using the same, so all the same. Then plus, again, theme. Now plot background element. Then react again. Then fill. I will use, oops. Light blue. Like this. So whatever color you like, fill like this. So panel, and then flat background, and so on. So you know this command using a theme, and then you can see many different function and command. So you may try one by one. Then what happened? So anyway, we developed this scatter plot. So exam score and then anxiety variables. Looks like the relationship is like this. Anxiety level increase, and then exam score decrease, negative, but very much scattered. So we can like expect before we get our score, there is some relationship between anxiety and exam score, but not much because you know it's spread. Okay, so we developed a scatter plot using this R, and then next now. Okay, before we go next, let's take a 5-minute break. Quick break. I will be back 7:50, and then continue. I'll be back. Okay, I'm back. Elisa.
Hello. Sorry. Okay.
Your last name.
There you
Your volume.
go. Oh,
was the North last name?
North is my mom's last name,
Mm-hmm.
and Mosda is my dad's last name.
Mm-hmm.
Yeah.
You know, I checked next semesters in Normand. Then one of my undergraduate operations management class,
Mm-hmm.
one of the students' last name is like the same as you.
It's probably my sister.
Mm-hmm.
Yeah.
Mm-hmm.
She was like communications or journalism,
Mm-hmm.
but now she wants to be like business management.
Uh-huh.
So
So
yeah.
she probably your sister. Okay.
Yeah. Yep.
Mhm.
Mm-hmm.
I don't remember the first name, but the last name is the same as you. So, oh, that last name is not very popular. So, so maybe a relation you and the student has a relationship. But
Mm-hmm.
yeah, that is my guessing.
Yep.
Okay, next, Pearson correlations. When we do correlation analysis, many different methods. Based on what statistician developed. So we can use like Pearson correlation analysis, Kendall's, and other people's name. But the most popular correlation method is Pearson correlations. So when we say just a correlation analysis, then mostly probably Pearson correlation. So using this function, we can do so using so that means correlation analysis using exam data, and then variable is exam as X variable. Actually, it doesn't matter. Exam as X variable, and then anxiety as the Y variable. And then using complete observations. So we can use everything or observations, complete observations. You know, earlier when we do this correlation using R commander, then we checked complete observations. You know, if data set has kind of missing data, then if we use everything or this all observation, then maybe the results show a kind of error. So we will use complete observations. That means you know, x variable, y variable. If there is missing variable, then get rid of. So completely x and y variables match data. So we will use this complete observations. And then method Pearson. So type this in RStudio. Here, COR, enter, then exam data, what variable? I will use exam, and again, exam data, what variable? We will use anxiety variable, then use complete observation dot complete observations, and method will be Pearson. Okay, here correlation between exam and anxiety variables negative 0.4409934. The same as using the result from the R commander. And then, you know, we did this correlation analysis using two variables. But if we want to know more variables, then we can command like this using this function. Go back. So we will do correlation analysis using three variables. You know what? Like just like in the COR correlation, exam data, then just type an error. Because in this data set, not numeric data included. So we should specify one by one. Exam data, bracket, comma, C, because now this one is multiple. So using comma C and then open parentheses and specify one by one. Exam variable and anxiety variable. And the last, revise variable. Enter. Then we can get a matrix like this. So exam correlation is because they are self. So anxiety and exam negative 0.44, and the revise variable and exam variable. R score is 0.396. Then anxiety and revise very high. Actually, very low. Negative 0.70. So highly negative relationship between revise and anxiety. Let's try to draw using anxiety and revise. Okay, anxiety, then I will. Okay, revise. Oops. Okay, let me see. Yes. So if we use anxiety and revise variable, then as you can see, 0.7, negative 0.7. So this one is not more obvious than anxiety and exam data, because it's a higher negative correlation between revise and anxiety. So on graph, we can see like a direction. Okay, next, let's see. Then, you know, earlier we used this function. Then we can make metrics like this. And then use other function, correlation, R correlation, this function. To use this function, we need another package, HMISC package. So first install this package and then execute, and then using this function. Okay, let's see. So install package and HMISC package. And then library HMISC. If we use this package and then using R correlation function, we can get p-value. So let's see. R, CORR, this function as matrix, and using exam data, and then comma C, exam variable and anxiety variable. Revise variable, enter. The result, this result is the same as this when we use the COR function. In addition, this result R score like a table or matrix. This one gives p-value matrix. So that means exam and anxiety exam the same. They have whatever relationship, correlationship, statistically significant relationship, and then all looks like all of them has a relationship. So using this function, we can get p-value like this. And next one, confidence intervals for correlation coefficient. Go back to this p-value matrix. But we don't know exactly if they have the statistically significant or not. So using this COR test function, then test if they have a significant relationship. If we use Excel, then we test this using t-test. So in R, we can use this function to individually t-test. Okay, let's do. COR dot test, two variables, exam data, anxiety, and exam data. Exam data at which one, anxiety and exam. The result, I will change the screen. The test result, t-test statistic is negative 4.938. Degree of freedom is 101. P-value is 0.00003128. So very small. If this p-value is less than 0.05, because this one used 95% confidence interval, then means alpha is 0.05, significance level is 0.05. So if p-value is smaller than or less than 0.05 alpha, then we can say it is significant. So because this p-value is very small, less than 0.05, so variable exam, anxiety and exam variables, they have statistically significant correlationship based on this test, t-test. And then, interval at 95% confidence interval, plus minus like a 95% kind of range. So it can be moved between negative 0.58 and negative 0.27. The confidence interval of this correlation between anxiety and exam variable is between these two values. And then they are significantly correlated. Okay, next. R square. R square is just the square of R. R scores like this. Then square. Using this R, we can do it. So to do that, if we use just the exam data, then because there is non-numeric data, so using exam data itself, then the result will be it will show error. So I'm going to make another data set. So using only get exam anxiety and revised variables, because the data set here, the exam data, the variable is they are revised exam and anxiety gender variables, but gender variable is not numeric data. So we need only numeric variables, revise exam anxiety. So I will make another data set. So exam data, I will name data 2, then put exam data in exam data only. Exam variable, anxiety variable, revise variable. So exam data 2 data set, only numeric variables. So we can make correlation directly, COR, and then exam. If just to try, I just try. If we just exam data, then error sign, because there is non-numeric variable in there. So, but if we use exam 2 data, then we can get the R scores. So R scores like this, then you know, R square is the square of R. So exam data 2, and then here square, using this sign and then square, enter. So this is an R score and this is an R square. You know what does it mean? The R square. You know, R explain there is a relationship, if there is a relationship or not, and then it show a direction, negative relationship or a positive relationship. But R square always positive, because the square of R, this means exam and anxiety. So earlier we see that the anxiety level increase and exam score decrease. So how much? Anxiety level explain exam score 19.44%. Not much, but anxiety level explain exam score at 19.44%. How about here? Revise and anxiety about 50% explainable. Revise and exam about 15%. So not much, but anyway, there is some parts exam score explained by anxiety and revise variable. That is R score, R square. And next, oops, that's R. You know what? Correlation analysis. Some of you already know. Some of you just the first time. But anyway, this correlation analysis is one of the important parts in statistics. So I cover using R. Okay, that's all. That's all.